Okay, well, this video is going to be about the WinJupos program, which I'm pretty new at, but starting to figure out a little of. And what I want to do is derotate a series of images of the planet Jupiter. So I was imaging it for, in this case, I'm going to have about 30 minutes worth of captures, where each run was a couple minutes or so. And we'll derotate it into one image, and the idea is it gives you better detail across the image. Works a lot better if you get a few hours, because I think it takes almost 3 hours for the red spot, for example, to go from one side to the other. So that'll give you better detail within. I'll show you a little something there. So here's an animated GIF I just made from images I took of Jupiter a year ago. So this was November of 23 when we were at opposition, and of course now I'm getting ready for opposition in December of 24. And this is about 30 minutes worth of captures. And as you can see, the red spots moving around. But the idea is you notice the best details really in the center. As you start getting over to the edges, it gets more fuzzy. And that's really because you're taking an image of a great big ball, and the part more in the center is facing towards us, and you get over towards the edges, it's actually facing out sideways. So the idea is to combine all of them into one image. If I didn't mention it already, I made this animated GIF in Pip. I made a little video on how I did that. That's a pretty cool little program. So now back to this. So in case you're not familiar with the WinJupos, it's been around a good 30 years or so, I guess, and if somebody created it to save a bunch of information on Jupiter so they can track storms and all that, and they can do all the planets and the sun. And so first thing, you need to make sure you got set for the right planet. So in this case, it's going to be Jupiter. And I've got it on English. And then we'll go over here to the recording tab and open a picture. It's not going to have file open. Oops. So we're going to go down here to image measurement. Click that. And looks like I've already opened one up. And I'm going to have to line everything up with this grid here. And a lot of times when you get it, the grid will be way off center. But this time, since I'd already played with it, I think it's kind of snapped itself close to it. But if I hit, one of the first things I want to do while I'm thinking about it, there's your North Pole and your South Pole. And I believe the red spot is supposed to be in the southern hemisphere. So what I want to try to do here is rotate the image 180 degrees to put that down in the southern hemisphere. And I got in the help file, and I'm supposed to hold down Control and Backspace at the same time. And of course I got to do it on the Adjust tab. So there, that did that, and it actually flipped both. But now if I hit just Backspace only, it puts the North Pole of the grid back up there and leaves my red spot down. But my lines still aren't lined up. So since it's Jupiter, there's a couple things you can do. We'll go down here to outline frame. You can click automatic detection, or as you see, you can hit the F11 button. And yay, it lined it up. And it also changes the diameter of the grid too to match up the planet. So now we've got that part set up decent. And then I want to go back to this first tab to remember a couple things I've needed to mention. There's a file naming protocol with this program. And in my case, I was kind of fortunate. I captured these in a ZWO ASI Studio program that is just for the ZWO cameras. So I've got the right date format, and it goes, you can see, in years and then month and then days. And it wants to be in universal time. So where I live, I'm 5 hours behind Greenwich Mean Time over there in England. So it said it was at 8:02. It was actually 3:02. And it has the seconds here as a decimal of a minute, so it's 2/10 of a minute. And in my geographic location, if we want to get everything correct, like especially if you're going to transmit your information to the people that do this, they can actually use them. I haven't figured out how to do that yet. So where I live here in around Terre Haute, Indiana, is 39 degrees and about 20 minutes north. And in my latitude, since I'm in the western hemisphere, is going to be minus. And I'm at about 87 degrees and 18 minutes. And I can save it in there, so it'll be there the next time. So I'll just name that real quick. See the name of my fancy observatory where I set up out in the driveway. See also, now I'm thinking about it, if you happen to use fire capture for capturing, I was watching a video, and on it, you can get in your settings and select universal time, and you can also click a little box that says something to the nature of use WinJupos format to name your files. So otherwise, you'd have to type in all this stuff for each and every frame. And if you got a whole bunch of them, that's a pain. A lot of information on here, too. You can open up your ephemerides, which is just all the information for that date. Well, I don't see anything on the gray red spot, but it does have moon coordinates, so it'll tell you where each moon's at. It's got a whole bunch of little stuff there. We'll get back to where we were dealing with to begin with. Okay, so this should be satisfactory here. And you have to do this to each image that you're going to derotate. So in this case, I've got, like I say, I think 11 of them. So it won't take too long to do them, to open each one up and click it and do the save. So right now what I got to do is here I'm on the image tab. I'll click save. And it's saving a file type called image measurement settings. So it's a .ims file. So I've created a WinJupos folder here to save them in. And I'll just save it. And then I got to do the same thing for each of the 11 files. So I'll pause and do that and then get back with you. So once I start to get kind of a rhythm, it goes fairly quick for each one. So I'll open. I just did 805. I want 808. Opens it up. I'm going to ignore that artifact. I can get rid of it later. Press F11 and it kind of tweaks the grid a little bit. Go back to the image tab. All this other stuff's set, so I didn't have to change it. Don't have to enter everything with every image, since I've got the right file format. Click Save. Go into the right folder. We'll just keep doing that till we got all of them. So I'd like to do one where I go way across, and you see that'd be kind of tedious if you have 100 images or something. Now, one thing I kind of like, I can see my UT time here, so 812 is the most recent one. Makes it easier for me to figure out which one I need next, especially if you're doing a lot of files. And also, on Jupyter, you can do this F11 thing. Apparently, that's the only planet that works on. You got to do it manually with others. So I hope to be doing it with Mars later, and I'll make a video after I learn how to do that too. Okay, so I've got 11 of them saved, and you see here this is my folder just to show you what they give me. There, looks like there's 2 files for each one. And you notice they give you a whole lot of information here too, which I think these are supposed to be different cloud bands, the CM1, 2, and 3. I don't know all of them. And if I get down to the bottom, got all my file information, tells me my planet is 292.3 pixels in diameter, and my image scale is 0.1693 arc seconds per pixel, and it got something about the rotation, what angle it is. I don't understand all that quite. And on this last one, you might notice there's a little bitty circle up here. There's a moon starting to peek out from behind Jupiter. I had captured several more frames, but the cloud went through or something. It started getting really bad, so that's why I'm not doing more frames to derotate. So next, for the derotation, we get up here on this top set of tabs, and we go all the way over to Tools. And on Tools, we go down to derotation of images in this case. So in this case, I've got a color image. If you had a mono camera, I think you would use the derotation of separate RGB frames. And you can also derotate a video stream. So we'll go derotation of images, and then we gotta open up all those little IMS files. And another spot that doesn't have file open, and we have this derotation of images tool open, and we go over to edit. You'd think you go open, but you don't. You go to add, and we're going to be adding these IMS files. So I got to find the correct folder. So now we got these 7 WinJupos files. Open them, and here it shows kind of a graph of all the rotation. And what it did too, it sets a reference time here. So it's going for the center. So my first image was at 7:59. And my last one was at 8:30. So 8:15 fell in the middle. And you can notice it's got all kinds of other stuff here. Your destination directory and everything you can change. And we'll go over here to compile image. Should give us a picture here in a few seconds. So the red spot had moved, say, from one side to the other, and this is in the center. And it should be subtly better. If I had a lot more frames, it would be noticeably better. Now, in this particular image, it's hard for me to see the improvement, but what it amounts to, since this is so few number of frames, some of the subtle details, or maybe it's a little difficult to see a faint spot in the clouds, would improve the contrast with that, so you'd be able to see a little more. And as you go out to the edges, if you have a lot of frames, it'll get better. So Anyway, this should give you an idea of what you can do. And like I say, it should be a lot better if I captured, say if I was able to follow the red spot way across, then my image should be sharper all the way across.